So let's look at the second half of this chapter. This deals with population demography. And demography is the statistical study of populations. So this looks at how populations will change in the future, and it looks at influences on that population size. So looking at influences on that population size, one of the things that we look at are the age structure. And so with age structures, we look at what is known as a cohort. And a cohort is a group of individuals of the same age. And so this is looking at a life table where you follow a cohort. So this is their first year, number alive, proportion alive, deaths during that first year. As you can see, the death rate was pretty high in that first rate. Most of these birds did not make it past that first year, okay? In fact, 2/3 of them did die, all right? So, we do this in schools, right? So this is showing a cohort of, some women who were in school in 1973, and here they are in 1999. You can think of your cohorts through school, the students, the people you went through K through 12 with, and so on. So that would be a cohort. One of the things we look at with those cohorts is looking at their fecundity, and that is the number of offspring produced in a standard time. So another way to look at that is the birth rate, how many births per year or per decade or stuff like that. Another thing we look at is mortality, and this is the number of individuals that die in a standard time. So, or death rate, right? So when we look at growth, population growth, that's the difference between fecundity and mortality, all right? So, next is a sex ratio. Sex ratio is also going to influence the population. So this is looking at the proportion of males and females in a population. And usually the number of females is directly proportional to the number of births. So if you have more females in that population, you're going to have more offspring produced that year, all right? So with harem species, harem species is like lions or elk or peacocks, okay? Here the number of males makes little difference on the growth, all right? So because you typically only have one or two males, it's going to mate with several females, all right? Versus a monogamous species, there the number of males has a greater influence on the growth of the population. And that's because, for like songbirds and stuff like that, is that both birds are necessary for the development of the offspring. So, the offspring are dependent upon the males. Or in harem species, the offspring are not dependent upon the males. All right, so let's look at survivorship curves. And survivorship is a percentage of the original population that survives to a given age. All right, and so there are three curves here. And the first is a type 1 curve. So that's shown here in the blue line here. It says most individuals live out a long lifespan and they're going to die old, right? So we do not have high infant and childhood mortality. They live for a long time and then they will die old, all right? So these species have few offspring at a time, all right? There's really not a whole lot that are in this group, and I really don't like them putting giant tortoises in that group, even though they live out a very long time. They're probably not in this group. So these are things like humans. We typically survive that. We live to a long age and die old, right? Elephants are in this group. Mountain goats are in this group because mountain goats live in areas in which there's relatively few predators. So, they survive there, and then when they get old, just like all old people do as well, you lose agility, and then mountain goats will literally fall off the mountain. So, next is a type 2 survivorship curve. So this is where individuals die at a constant rate. So here, they have an intermediate amount of offspring. So you can see, a common kingfisher here. A lot of songbirds are this. So they die at a constant rate. No big drop at the beginning there. Lastly is a type 3. A lot of organisms are in a type 3. Here, most individuals die young. If they do survive to be an adult, they're going to live to be a long time. And this is actually where turtles are found. Most turtles are found here. They have a high mortality rate while they're young because they're small, more susceptible to predators. But once they get that nice hardened shell around them, it's really hard to kill them, so they live a long time. right? So, you know, if you ever like, oh, I'm going to take this turtle here, you know, you could have that turtle for the next 20 years. So they'll live that long. All right, they typically produce a lot of offspring, so you think of spiders and insects and so on. Once again, high predation rates when they're young. A lot of fish are in that category as well. All right, let's look at age distribution. So this is a proportion of individuals in different age categories. And there are three major groups. We have a pre-reproductive, we have a reproductive, and a post-reproductive. So, you know, looking here, here's pre-reproductive, here's reproductive, here's post-reproductive up here, okay? So there are three kinds of age distributions. One is a pyramid shape. In a pyramid shape, you can see that pre-reproductive is large, the reproductive is smaller, and then the post is even smaller. And this indicates a population that has very high birth rates, and this population is actually undergoing exponential growth, and that's what we see there, okay? So Kenya would be a good example, although, you know, you can see this last line is less than the previous line. So they're sort of slowing down, all right? And why they're experiencing exponential growth is because they're getting, you know, modern things like, you know, vaccinations and sanitation, and so that's allowing more children to survive, right? So the biggest thing that's declined human population size over the years has been high infant and childhood mortality, you know, mainly through diseases. Prior to 1900, 2 in 5 kids died before the age of 5. That has drastically changed due to the fact that we have vaccinations and sanitation. So, you know, you're not drinking water that you've put waste into. So that's what sanitation has done for us. And vaccinations are eliminating a lot of these diseases that would kill younger people. All right, next is a bell shape. So if we go to, this is showing human, or not human, but this is showing the United States. So this is a bell shape. Here, the pre-reproductive and reproductive are relatively nearly the same, and that's what we see here. You know, so here we're about the same, even though this line's right in there in the middle. All right. So the post is the smallest, just due to mortality, which it is in all groups. This is a stable population. So the United States pretty much has a stable population size. The only growth that we really have, so the average woman has 2.1 children, right? And so that 0.1 actually, you know, die before they get to be an adult. So right there at just replacement. So if a woman has 2 kids, that just replaces her and her partner there. All right. The only growth that we have is due to immigration that is occurring in the United States. The last type is called an urn. So this is an urn, and so this is where the post-reproductive is large and the pre-reproductive is small. So when we say post-reproductive is large, it's relatively large. Like if you look at this post-reproductive in comparison to this post-reproductive, it's much larger here in Norway than in comparison with Kenya. Here, the birth rate is actually below the death rate, and this shows a population decline. In Norway, isn't so that urn, it gets a little wider here in the middle. All right, and so Norway isn't the only one that's like this. Italy is also like this. Japan is also like this. So their birth rates are, the average woman has less than 2 kids, and so that shows a population in decline.